Thickets and theories. I'm in the dense forest of Vieques, entangled with dense ideas at the roots of reality. I'm in wilderness because I struggle to learn how the world works. I'm enduring mosquitoes because I strive to get the latest science. Vieques is an island in the Caribbean Sea, 8 miles off the Puerto Rican mainland. I'm here attending a conference on the physics of information. Information is all the rage in science today. More than once I'm advised, unless you understand information, you cannot appreciate the forests or the trees. I hope I can get through these concepts better than I can get through this underbrush. I need to start with basics. What is information? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Scientists are talking heatedly about information as essential for exploring the foundations of the world, for accessing the deep nature of reality. Why the scientific excitement? How to discern the meaning of information? That's the purpose of this conference, organized by the Foundational Questions Institute, FQXI, which brings together physicists, cosmologists, and philosophers of science to discuss and debate over-the-horizon ideas. FQXI takes risks and explores controversial topics. But why Vieques? Perhaps it's primitive nature. Perhaps it's isolation. Perhaps to commune with nature in order to penetrate its secrets. I start with the scientific director of FQXI, cosmologist Max Tegmark, a fount of big ideas. Max, it's so great being with you here on Vieques in Puerto Rico at FQXI, the Physics of Information Conference. How do we deal with the physics of information? What is it, and why is it important?
We used to think it was utterly unimportant. We used to think information was just some sort of sideshow that statisticians liked that had very little to do with physics. And then, remarkably, information has started to crop up in area after area of physics in a very fundamental level. We've come to learn that in quantum mechanics, many of the deepest theorems and questions can be rephrased in terms of information, and the whole field of quantum computing is about harnessing a new kind of information, quantum information, to do things we previously thought were impossible. Then in relativity theory, in our attempt to unify that with quantum mechanics and do quantum gravity, information has again seemingly cropped up as super important. On a third front, we have a lot of neuroscientists here at our conference who are arguing that studying information processed in physical systems is also the master key to understanding one of the deepest mysteries of all, that of consciousness. This really makes me wonder if one of my greatest heroes, John Archibald Wheeler, was right when he talked about it from bit and argued that maybe information is not just some coincidental little thing, but maybe information is really, truly fundamental, and maybe it's even more fundamental than matter and energy and space, so that we can maybe ultimately either understand how those things we thought were the building blocks of physics emerged from information, or at least unify everything with information.
So do you see this as a trend where information, ultimately it may be the ground of physics?
It certainly seems to me like that's the way the wind has been blowing for a long time in physics. So the idea was to bring together physicists and other scientists working at the forefront of many different areas of science that were all focused on the role of information, and trap them here on this small island where they had no choice but to talk with each other in the hope that this sharing of ideas would help them realize that, maybe there are deep connections here. Right, Max, it's working. Trapped on this small island, surrounded by impenetrable woods and rough seas, scientists who'd never crossed paths compare notes. Information is a deceptive term, a common word we think we easily understand.
But information in a technical or scientific sense is disruptive, with power to enlighten and advance knowledge, and somewhat challenging to understand. The plan, the hope, is that interdisciplinary thinking can enrich information. And I meet the personification of interdisciplinary, Paul Davies, physicist, cosmologist, exobiologist, and cancer theorist.
If you go to a dinner party and talk about information, everyone seems to know what you mean. And these days, we're so familiar with it, it's almost as if it's got a life of its own, that it does stuff, that information seems to have some sort of causal power. And we construct narratives around what information does. It affects the world. Now, clearly, it does affect the world, but so does matter. So what we would like to know is how matter and information fit together. Is there one lot of laws governing information and another lot of laws governing matter? Well, they better be compatible. Every time we see information, it's instantiated in matter. It doesn't just float around in empty space. It's got to be attached to something. And so this presents a bit of a paradox, because physicists are used to studying what matter does. Information tags along for the ride. So my interest in it is whether we can treat it as if it is the primary stuff out of which the physical world is built. Now that's a drastic step to say underpinning everything is information, but it's certainly clear that in some circumstances information is calling the shots, and the circumstances are right here when we have this conversation, because living organisms exemplify the power of information because they're really information processing systems. Now, we're familiar with the term information processing from computers. Computers have been designed by human beings. We like to suppose that living organisms haven't been designed, they've evolved. And so how's this information processing emerged from the clamor of molecules just banging into each other in some sort of chemical soup? That's what interests me these days. It's the emergence of information processing systems that we call living cells.
So how do living cells process information?
If you talk to a biologist, what is life? You'll be given a narrative in terms of things like the genetic code. Genes are instructions for cells to carry out certain tasks. Talk to a physicist or a chemist, what is life? And they give an explanation in terms of molecules and energies and interactions and so forth. So we have these two parallel narratives discussing the same thing. And what I would like to know is how the informational narrative emerged from the matter narrative, because we've got two different levels of description. How do we get one out of the other? You can't have some mix of properties of molecules that give you coded information. It's a different conceptual landscape entirely. Historically, matter has been at the bottom of the explanatory chain, and information has been a sort of secondary derivative of it. And so whilst we recognize that information makes a difference in the world, it somehow doesn't seem to be fundamental. But there's increasing interest among at least a small group of physicists to turn this upside down and say maybe at rock bottom the universe is about information and information processing, and it's matter that emerges as a secondary concept. And we're led to that because of quantum physics, where you interrogate nature and you get answers in terms of bits of information.
To Paul, information and matter energy are two ways of viewing the bedrock of physical reality. Like most scientists, he gives primacy to matter energy, but he recognizes the trend among physicists that centers information at the core of reality. Here's the crux of the issue. Is information only an analytical tool and helpful metaphor? Or does information lead to or become the ultimate source of everything? Seth Lloyd is one of the founders of the Information as Fundamental movement. A pioneer in quantum computing at MIT, Seth's information is writ large. How does he define information?
Seth, I want to understand reality, and you tell me I have to know what information is to understand reality.
Well, I'm not guaranteeing that merely by understanding information you'll understand reality, Robert. But yeah, information has a technical sense, which everybody's familiar with these days because we deal with computers and smartphones. And cell phones and communication systems that break up information into bits. So the bit is the smallest chunk of information. It represents a distinction between two possibilities, true or false, yes or no, here or there, or a little black pixel or a little white pixel on a black and white TV screen. So you can count the amount of information that you have in, for instance, what I'm uttering right now. I'm like creating it with my voice, in addition to the words that I'm telling you, which are, a few tens of bits per second. Then my voice and its timbre and its change has a few thousand bits per second. And if you look at this beautiful scene here with the ocean there, the visual information has a few million bits per second. This is, in some sense, a new thing that we can count information. For thousands of years, information meant, knowledge, meaning. But the weird thing is that in some sense, we've learned a lot more about information since we've been able to just count it and forget about the meaning. So, all right, maybe it means something, maybe it doesn't, but there are 70 bits. So like when the cable guy comes to your house, in order to connect up your cable, his job is to make sure that you get 1 million bits per second coming into your TV, and he doesn't care if you're going to use it to watch Shakespeare or porn. So quantity of information turns out to be a very fundamental thing in the universe. And by understanding the quantity of information, measuring how many bits of information are contained in an image, in a sound, in a word, we can learn a great deal about how the universe is put together. Gajillions of bits of information, and yet how much meaning is there? Well, I don't know.
So how then does information in the technical sense kind of bridge that gap? How does that help us get to what we call real meaning as opposed to amount of technical bits that would describe that meaning?
A good way to think of how information acquires meaning is to think of what information does. In his philosophical investigations, Wittgenstein has this great example of a carpenter. The carpenter is an assistant, and when the carpenter says hammer to the assistant passes her a hammer. Right? When the carpenter says slab, the assistant passes her a slab. And from the assistant's actions, we infer that the assistant knows what the carpenter means. There's a situation where Wittgenstein is trying to tease out the meaning of meaning. And by just looking at how information makes people respond, what information does. So if we look not just how much information there is, but what information does, then we can learn a lot more about how meaning comes into existence. And the way we understand that nowadays is, in fact, in terms of computation. So a good way of understanding meaning is to look at these actual physical digital bits that we collect on camera, that we go into our cell phones, and that get processed by our computers. For instance, in a computation, this bit here means do this. So the bit is an instruction, and the computer has lots of bits in it already that allow it to figure out what it's doing.
So what is the significance of understanding information in this new technical sense?
At a physical level, information is everywhere. So if anything that can be in one of two different states can store a bit, then any atom, any molecule can have a bit of information. So in that crashing surf out there, every molecule of water, by its configuration, by its rotation, by its position relative to the other water molecules, it carries with it bits of information. And then whenever any two water molecules collide, they change and process that bit of information. So one way to think of two water molecules in the surf colliding is, it's just a bunch of water molecules colliding, okay? But another is that what this water molecule does is a function of the information that this water molecule contains. So if it strikes it in this way, this water molecule goes off in some way like that, whereas if it strikes it in this way, it goes off like that. So you can think of this water molecule as essentially instructing this other water molecule what to do.
But is this metaphor or is this reality?
The traditional way to describe the universe is that it's made of energy. E equals mc squared. Every elementary particle, every electromagnetic field contains energy. And we describe it physically in terms of the dynamics of how it changes over time. But merely by existing, these elementary particles and fields also contain information. They're made of energy, but information tells us the form that this energy takes. So the fact that this chunk of energy is an electron and this other chunk of energy is a photon, a particle of light, that's information. So the universe at bottom consists not merely of energy, but of information. Merely by existing, everything contains information. And whenever something changes, so electron absorbs a photon, that information is processed. Bits flip. Now, bits flipping is a computation. So just as it's real to say that the universe is made out of electrons and electromagnetic fields and photons and elementary particles, the universe is also really made out of information, and the way the universe changes over time is really a computation.
To Seth, information and matter energy have equal claims as the source of fundamental reality. His fresh thinking describes interactions among fields and particles as computation, along with the usual mechanics, classical and quantum. He claims that all changes in the universe are computations. Am I being persuaded that reality as information is more than metaphor? I can't tell. I don't have enough information. If the universe at bottom is information, as Seth says, we should find it affecting diverse areas, perhaps enabling solutions to intractable problems. That's why FQXI, for the first time, invited neuroscientists to interact with its physicists. What happens when the concept of information is applied to the content of consciousness? Consciousness inner awareness is perhaps our biggest mystery. Could information be the underlying explanation? I meet neuroscientist Giulio Tononi, who originated the integrated information theory of consciousness.
So at this meeting, we have heard all kinds of definitions. There are the classic and very powerful one, like Shannon information is the one that you transmit across the channel, trying to recover a signal. There is Kolmogorov information, which is how can you compress a pattern and so on. They're all very important, very useful, and very powerful. But the information we're talking about here is intrinsic information. It's information from the perspective of a system itself, not from the perspective of an observer who wants to use the system to transmit things and store things. It is what is it like to be a particular system. And the short answer is it can only be the difference that make a difference to the system itself. So that's the intrinsic part. And the difference that makes a difference is what is captured exactly by the integrated information theory. Things that constrain the past and the future of the system, and they do it above and beyond the part of the system. Otherwise, there would be no system at all.
Is the nature of information, even though it's internal and intrinsic, of the same character, or is it just using an English word that sort of sounds right but is fuzzy?
No, it's radically different. So, for instance, I can say that we form a system, you and I, okay? And we are certainly talking to each other. And in some sense, somebody could use us to transmit information, as on the phone, and store information. I tell you something you keep in mind, then we'll recover it later when I ask you again. So we can be treated by a physicist or by a computer scientist as an information processing system or storage system of some sort. But that tells us nothing of the fact that there is one there and one here, and only those two. So the information from the inside exists only somewhere in your brain there and somewhere in my brain here, and not really anywhere else in between.
Can it be expressed in numbers? Are there mathematical equations that can be used to describe it?
That is the whole point about integrated information theory. It is indeed a set of numbers. You can indeed describe it as a mathematical structure. But it happens to be also what we are.
But being a mathematical structure seems like such a different category than the perceptions of internal phenomenology. It would just seem theoretically impossible that numbers could describe the experience that I have.
Well, you see, Galileo said famously in the Essay that in order to do science, we would need to use the language of mathematics because reality is built, he said, of triangles and circles and figures like that. He was referring to the outside world because he had the foresight of saying, let's forget the observer at the moment, let's look at the outside world and describe it. And then it speaks the language of mathematics. That's what his great insight was. I think, in a way, the idea here is to forget about Galileo and go inside ourselves and ask about the observer itself, ourselves, our consciousness. Well, that, too, I think speaks the language of mathematics. In fact, I think it's mathematics itself. So that's what I think the bottom of both a description of the physical world and the description of consciousness is, if you wish, mathematical structures.
Giulio's information is its own special kind. intrinsic information, what information is from the inside, from the perspective of the information itself. It's a radical notion, and perhaps transformative for consciousness. Right now, consciousness, what it feels like inside, remains a complete mystery, notwithstanding all the neuroscience. And so one test for any proposal to explain consciousness is not whether the idea is too radical, but whether the idea is radical enough. I can follow this path, but not too far. Is mathematics both the foundation of the physical world and the generator of consciousness? Not just describing or modeling them, but literally being them. Well, I'm not there. Yet. Still, I seek the deep nature of information, and still there are areas I've not explored. Information, I've learned, is tied to computation, which now includes quantum theory. I find MIT's Scott Aaronson, an expert on computational complexity and quantum information theory.
Well, information is one of those things that's hard to define in terms of something more basic. It's a way of measuring the number of possible configurations that a system could be in. Or another way to say it is it's a way of measuring how surprised you are upon learning something, right? How much do you learn? So the standard unit of information, of course, is the bit. And a bit is just anything that can be in one of two states, 0 or 1. Or you could say an electron in its ground state or in its excited state. So because of the computer revolution, I think we're now very used to this concept of information as an abstract entity.
The use of information in diverse fields from physics, biology, is it the same entity, or is it a way of measuring, or is it some fundamental aspect that we're looking at?
Well, there is a mathematical definition of information, which was given by Claude Shannon in 1948. Basically, Shannon's definition gives you a way to measure the number of bits, but even in very unusual contexts, right, where you might not think that you could. So, for example, you can measure the number of bits per letter in English text. Okay, and you might think that, well, okay, there are 26 letters in the English alphabet, so that's between 4 and 5 bits. But it's actually somewhat less than that, because English has regularities. The letter E is very, very common. The letter X is not so common, right? And so because of those regularities, there are fewer bits. There's more predictability in English than if it were just a completely random jumble of letters. And it's a very general definition in that you can apply it to DNA, you can apply it to counting the number of states of a black hole, for example. You can apply it to anything, you know, in any field of science.
How about quantum information, which you work in very intensely?
Yeah, so quantum information obeys qualitatively different rules than we're used to from classical information. I mean, many people have heard of, you know, the famous Heisenberg uncertainty principle that says, you know, you can choose to measure a particle's position or you can choose to measure its momentum, but you can't measure both to unlimited accuracy. What this really means is that quantum objects or quantum information has a degree of privacy to it because there's something called the no cloning theorem, closely related to the uncertainty principle, that says if you have, let's say, one electron in a particular state, there is no physical process that can produce a second electron in exactly the same state. You would have to measure both the position and the momentum of the original electron, but you can't do that. And people have actually figured out how to exploit this idea recently, so that in principle you could have quantum money, for example, that would be physically impossible to counterfeit, okay? So a whole field has grown up to sort of just understand how quantum information behaves, how it relates to classical information. Because of the weird rules that it obeys, you know that when you weren't looking at it, you know, it had to be behaving as quantum information.
It's no revelation that information is changing society. What's novel is that information is changing science. Why is information so hot? How to see the new landscape of information. Information as facts or knowledge, things one can learn. Information as measuring difference or surprise, how much you learn. Information as one of two opposite states, on, off, yes, no, 1, 0. Information as the mathematical description of a communication system. information from the inside as intrinsic to a system, information as quantum information, entangles states with vast potential for computing power, and taken together, information as power, to explain and perhaps to cause. From the forests and seascapes of Vieques, I have new respect for information, as both metaphor and reality, process and substance, form and content. Surely, information is closer to truth.
For complete interviews and for further information, please visit closertotruth.com.